Welcome back to the channel. Today, we're diving deep into the fascinating world of data. Whether you're a student, a professional, or just curious, understanding data is a fundamental skill. We'll demystify how to classify data, compute key descriptive statistics, and recognize common data shapes, giving you a practical toolkit for making sense of information. Let's start with data types. The first is nominal data. Think of categories without any inherent order. Examples include colors like red, blue, green, or types of fruit like apples, bananas, and oranges. You can count them, but you can't logically say blue is greater than red. It's purely for labeling or naming. Next, we have ordinal data. This type also deals with categories, but there's a clear, meaningful order among them. Consider survey responses like dissatisfied, neutral, satisfied, or very satisfied. While there's an order, the difference between dissatisfied and neutral might not be the same as the difference between satisfied and very satisfied. The intervals aren't necessarily equal. Moving on, we encounter interval data. Here, we have ordered data with equal intervals between values, but no true zero point. A classic example is temperature measured in Celsius or Fahrenheit. The difference between 10 and 20 degrees Celsius is the same as between 20 and 30 degrees, representing an equal change in heat. However, 0 degrees Celsius doesn't mean the complete absence of temperature. You can't say 20 degrees is twice as hot as 10 degrees. Finally, ratio data is the most informative type. It possesses all the characteristics of interval data, order, equal intervals, but critically it has a true, meaningful zero point. Height, weight, income, and age are all examples of ratio data. Zero height means no height at all, and someone who is 2 meters tall is indeed twice as tall as someone who is 1 meter. This allows for meaningful ratios. Now that we can classify data, let's explore how to describe it. We'll begin with measures of central tendency, which tell us about the center of our data. The mean, often called the average, is calculated by summing all values and dividing by the count of observations. It's widely used but can be heavily influenced by outliers. The median is another crucial measure of central tendency. It's the middle value in an ordered dataset. If you arrange all your data points from smallest to largest, the median is the one exactly in the middle. If there's an even number of data points, it's the average of the two middle values. The median is robust to outliers, making it a good choice for skewed distributions. Our third measure of central tendency is the mode. This is simply the value that appears most frequently in your dataset. A dataset can have one mode, multiple modes, or no mode at all if all values appear with the same frequency. It's particularly useful for nominal data, where mean and median are not applicable. Beyond the center, we need to understand the spread or variability of our data. The range is the simplest measure. It's the difference between the highest and lowest values. While easy to calculate, it's highly susceptible to extreme values. Variance, on the other hand, measures how far each number in the set is from the mean. We calculate it by taking the average of the squared differences from the mean. The standard deviation is perhaps the most commonly used measure of variability. It's simply the square root of the variance. Why take the square root? Because it brings the measure back into the original units of the data, making it much more interpretable than variance. A small standard deviation indicates data points are close to the mean, while a large one suggests wider dispersion. Moving on to positional measures, percentiles help us understand where a particular data point stands relative to the rest of the dataset. The PTH percentile is the value below which p% of the observations fall. For instance, if you score in the 90th percentile on a test, you scored better than 90% of the other test takers. Quartiles are specific. Percentiles, the 25th, 50th, and 75th percentiles. Now, let's talk about data shapes, or distributions. One key aspect is skewness, which describes the asymmetry of the distribution. In a perfectly symmetrical distribution, the mean, median, and mode are all equal. If the tail of the distribution extends more to the right, it's positively or right skewed, with the mean typically greater than the median. If the tail extends more to the left, it's negatively or left skewed, and the mean is usually less than the median. Another shape characteristic is kurtosis, which describes the tailedness of the distribution, how many outliers there are. A normal distribution, often called a bell curve, is mesokurtic. Distributions with heavy tails are leptokurtic, while those with light tails are platykurtic. Understanding these shapes helps in choosing appropriate statistical tests and models. In conclusion, mastering data types, descriptive statistics, and distribution shapes is fundamental to unlocking insights from any dataset. By correctly classifying your data as nominal, ordinal, interval, or ratio, you can choose the right measures like mean, median, mode, variance, and standard deviation to summarize its central tendency and variability. Recognizing skewness and kurtosis helps you understand the overall form, enabling more informed decision-making. Keep practicing, and you'll be a data master in no time.